So we're going to talk about ionic compounds and a little bit with naming hydrates, and that's going to help us as we do a lab later on in the semester. All right, so if you recall, a cation is a positive ion, and it has a plus sign in the name. Okay, cations go first, and it's going to take the same name as the element. So we're talking about, and we did this on the first day of the unit. If we have sodium chloride, which is salt, sodium goes first. And y'all know sodium, as a cation, has a charge of 1+, right? So it is the cation, and typically it's going to be the metal. The metal goes first. And a good rule of thumb when you're naming compounds, and this works for covalent as well, the thing on the left-hand side of the periodic table goes first. Just like you're reading a book, left comes before right. So if you look up on the periodic table, sodium is on the left, and chlorine or chloride as an ion is on the right, so it goes left to right. So that's a good way to remember it as well. The anion is written last, and so it is going to be the one whose name gets changed a little bit. And so bromine is changed to bromide. In this situation, your chlorine is changed to chloride. It wouldn't sound right to say sodium chlorine. That sounds weird. Okay, so you can always just go back to that as an example because you're already familiar with it. All right, so you need to know if an element forms cations with different charges. So what I mean by that, these are the elements that are typically down in the D block, okay, and they can form multiple ions. So, for example, copper or iron, those are cobalt, those are really common ones. Those pop up a lot, okay. And so if it does, what you're going to do is you're going to specify the charge with Roman numerals. And so for the 5th time, the Roman numeral is not how many coppers in this situation we have. It's how many robbers we have. No, just kidding. That's not funny? I don't have any jokes. It's not how many coppers we have. It is how, it's the charge. Okay? So copper 2 sulfide is CuS. The reason it's CuS, let's think about it. Copper's 2+, because it told me, well, in this situation it didn't tell me, but I can tell here that it's 2+, and then sulfur's 2-, right? I have 1 of each. So the formula has 1 of each. And so sulfine's 2-, and so the copper has to be 2+ to make the compound neutral. So the 2, that 2, doesn't mean I have 2 coppers. There's only 1 of them. That's not the right answer. People always mess that up. That's not it. It's the charge. So, as we keep looking at these binary compounds, if we look at more examples, what's going to happen on your quiz later on? Let me kind of cover this. I'll put it up here. If I was just given CuBr and I was asked to provide the name, okay, you have to recognize that copper is in the D block and you need to give it a Roman numeral. Well, how do you know the charge? What you do is you make yourself a little chart. You don't know the charge, see that? And then you have bromide. Well, how many of each do I have? 1, 1, and 1. So I have 1 circle for each, 1 particle for each. I know that there is 1- sign in this particle of bromide. So what has to be in this one to make it neutral? 1+ sign. See how you got to work backwards on that a little bit? So, anyway, I know that the charge on this copper is copper 1 bromide, or copper 1, so I have copper 1 bromide. So, that's easy. Like, you can probably do that in your head. But as they get a little bit more complicated, this right here, you're going to have to provide the name. They're not going to tell you it's iron 3 oxide. They're going to say, name that compound. So, in this situation, what I'm going to do is I'm going to come up here and say, I don't know the charge of iron. But I know the charge of oxygen. Then I'm going to draw these 2 circles for iron. And then I'm going to draw 3 particles for oxygen. I know the charge of oxygen. So I have 6 minus signs. I have a charge of 6, negative up here with my anions. So how many plus signs have to be in each ion? Everybody. Yeah. So that means that I'm dealing with iron 3 this, that's fine. Some of y'all don't need to do it, but a lot of you do, and that's okay. You're still special, and I love you. Don't matter. Do whatever you have to do to be successful. So overall charge is 6 minus, so I'm going to need 6 plus. Let's do the math there. Pretty simple. Like I said, some of you can do it in your head, but some of you can't. All right, so what I want you to do is I want you to take your little whiteboards, and I want you to name these for me. So you're going to have to take the formula and give me the name. We were, at the beginning of the class going the other way. Watch out for your transition elements, those in the D block. If you need to talk to your neighbor, you're fine. It's not to be super quiet. And I'm just going to be coming around checking out. Fluoride is not spelled like flour in a pancake. It's spelled F-L-U-O-R-I-D-E. Here, man. So just kind of list these. You need to use the back or write smaller. When you're doing number 4 and number 6 and number 7, those are when you're going to want to use that shortcut I showed you if you need to. I see some people using sulfite, bromite. Do y'all see any polyatomic ions up here? Nope. If it ends in "ide," I'd look on the periodic table. Everything up here is just coming straight from the periodic table. So if it's coming straight from the periodic table, like sulfur, sulfide, bromide, I don't have the ITE. Ide. If it ends in "ide," I'd look on the periodic table for it. Oh yeah. So number 7 is CO, like cobalt, and then I3. As y'all finish up, I've been looking around and doing pretty well. I'm going to finally start showing the answers on the board so you can check yourself. I'll make a chart where I need to. more minutes to work and check your work. I'm seeing a lot of people on number 6, manganese. Let's find out on the periodic table. It's in group 7. It's in the D block, and it is not zinc or cadmium or silver, so it does need a Roman numeral. It has different charges. So you're number 6. Make sure that you're doing the Roman numeral. A lot of people skipping that. I think you're thinking of magnesium, and Mn is manganese. Mg is so since you're going from the formula to the word, it doesn't really help you because so what happens in one charge on number 6 and 7 it does, and it always is helpful to make sure that the words to the name are so if you use words to the other one, they will talk about it. Alright, let's take one more minute. Some people aren't finished yet, and that's okay. Which part? Yeah. It's a charge. Yes, exactly. Okay. Alright, so the people that aren't done, what they're struggling with, it seems like, is how do you know the 2 and the 3? So what I did when I worked these out is I'm going to kind of back up in time and show you how I start. On number 4, when I started number 4, I didn't know the charge of iron. So what I did was I drew an empty circle for iron because I don't know the charge. And then I knew sulfide was 2 minus. So if I have one of each and that's the same charge to balance each other out, then this one iron has to have 2 plus signs. It has a charge of 2 plus. So this charge, the number of plus signs, is the Roman numeral. Okay. On number 6, when I started number 6, I didn't know the charge of manganese. Don't get manganese and magnesium mixed up. Magnesium is always 2 plus. Doesn't need a Roman numeral. Mn down in the D block does. Okay. So check it out. I had 1 manganese, 1 oxygen, or oxide. So I left the manganese circle blank, and I drew in my 2 minus signs because I can tell that. Right? So I know to balance the charge to make them neutral, I am going to have a 2 plus charge of manganese. I start to click a little bit. Right? On the cobalt, I didn't know the charge of cobalt, but I knew I had 1 cobalt. So I had 1 cobalt and I had 3 iodides. So if I have 3 iodides, 1 minus each, then the 1 cobalt that I have has a charge of 3 plus. And I have 3 plus all together, right? So that makes the charge 3 plus. So it's called cobalt 3 iodide. A little bit better now. Alright. So to me, it's easier to go from the formula to the name than it is from the name to the formula. We haven't went this way much. We've been going the other way. Kind of get you ready for this. So maybe we do the other way. It might be a little bit easier. This it doesn't really help to make a chart unless it's a transition metal. Everything else, you're just going to name it what it is. Just lithium fluoride, whatever. You don't need anything special. All right. So if I name polyatomic compounds with polyatomic ions, if you don't look at something and see CO3 2 minus or CO3 and think carbonate, you have a problem. You don't know your polyatomic ions. So that's going to come back to bite you. And I tried to hit that off in the past by having you memorize it. So when it's a polyatomic ion, you're not going to add iod or anything. Iod is only for periodic table stuff, and then hydroxide and cyanide. Okay. So carbonate is the carbonate ion. Calcium carbonate is calcium carbonate here. Okay. Notice there's no 2 minus. Neutral. No minus signs there. For ammonia, it's the only cation ion that you need to know. It's the only positive polyatomic ion. So this is ammonium chloride. If you don't have ammonia memorized, you're going to look at this and be like nitrogen, hydride, chloride. You won't know what it is. But if you see NH4, you know it because you've memorized it. So NO3, 1 minus is nitrite. So that's ammonium nitrite. Nitrate, excuse me. With polyatomic ions, you just name them. You just call their name. You don't have to do anything, no Roman numerals, nothing like that. Okay? Only 3 of them end in "ide." So cyanide, hydroxide, and peroxide. We don't deal with peroxide too much, but it was on your sheet that you had, so that was something that was there. Everything else that ends in "ide" is a monoatomic anion. If it's monoatomic, that means it has 1 atom. Where is a chart that has all the 1 atoms? The periodic table. Things that end in "ide" are probably on the periodic table. Alright, so we've already learned polyatomic ions. There it is. Hypochlorite, 2 less oxygens, chlorite, 1 less oxygen, chlorate. That's our clam, right? Okay. Perchlorate, 1 more oxygen. You already know that. Sulfite has 1 less oxygen. If you didn't learn this, well, there it is one more time. So let's see if we can name these with polyatomic ions. Still keep your eye out for things in the D block. Do we see anything in the D block though? Looks like you shouldn't have any Roman numerals then. See? So this should go pretty smoothly. If it doesn't, that's okay. We'll talk about it. Get stuck, let me know. If you have any trouble doing this because you don't know your polyatomic ions, you need to spend some time on them. I will not provide them to you ever. So the way the chart works is, say I know I have calcium, and I know I have I give myself one, and then I ask what I need, and that's why I have one calcium. clock, you don't need Roman numeral. I didn't see number 1 as having copper, so I think I did all mess up. So I apologize. You see copper, iron, manganese, cobalt. Those are really, there's more, but those are the most common. Little light in your case, you go, and they should say, ooh, I need a Roman numeral. Now, what is the charge of carbonate? Did this way go a little bit better? Yes, because the carbonate, you have one of each, right? And the carbonate is not too bad. Carbonate, bicarbonate. It doesn't work. It means I have 4 electrons. So it can't. Alright, I'm going to put the answers up here, and I'm going to actually work out number 1 for you in case you needed it. So check your responses. Make sure you have it. On number 1, as far as carbonate goes, carbonate's 2 minus. So let's pretend you're taking your quiz. You don't know the formula for carbonate. You know that this is carbonate, but then you don't remember what the charge is. Well, if you don't know the charge of carbonate, you can't figure out the charge of the copper. So anyway, carbonate is, make myself a little chart. So here's copper, and I don't know the charge. And then the carbonate is CO3 2 minus. I have 1 of each, so the copper charge must be 2 plus. And then the 2 plus is the Roman numeral. Everything else is a matter of memorization. Okay? You just have to know that NO2 is nitrite. You have to know this acetate here. Sometimes we write acetate like this, and sometimes it's C2H3O2, and that's 1 minus. Oops. But they're the same. Why do they write it out like this? Because it's the way that the molecule looks. I'll catch you next year in chemistry if that's you. How are we feeling? Good? If you're uncomfortable about polyatomic bonds, again, make sure you're looking over there. Is there anything other than number 1 that I can work out for you or explain? Okay. So, moving on with our lives. When you recognize an ionic compound, you're looking for a metal or you're looking for some polyatomic ions. If you see either one of those things, it's ionic because covalent are only made of nonmetals. Okay? Writing Ionic Formula. So this is what we've already kind of been doing with the chart. So you got to make sure that they're going to end up having a neutral charge. So for calcium chloride, calcium's always 2 plus because it's in group 2. I tells you have chloride, which is from the periodic table. I look on the periodic table for it. And then chloride's always 1 minus. So what I'm going to do to go from the word to the formula is I'm going to make myself a little chart. Oops. I'm going to make myself a little chart. Calcium's 2 plus, chloride's 1 minus. Just start with 1 of each, okay? And then you'll notice that you need 1 more chloride. So if I'm going to write the formula, 1 calcium, and then 2 chlorides. I don't need any parentheses because I only have monatomic ions. I need parentheses for polyatomic ions, phosphate, sulfate, those things. This is what we've been doing. This is harder, so this probably may feel better for you. We haven't really went the other way with it. So this, look, if somebody in 8th grade showed you this doesn't work every time. It doesn't show any conceptual understanding, and it doesn't help you name stuff. This is a bad idea. I refuse to show you that. If you wanted to be that kid, you'd be that kid, but I ain't helping you. So iron 3 sulfate, taking a quiz, how do you do this? okay? The 3 on the iron tells us the charge. So I'm going to start making my little chart. That charge is that Roman numeral, or backwards, I should say. That Roman numeral is the charge on iron, that cation, and then sulfate is SO4 2 minus. So I'm going to give myself one of each, kind of start that way. I notice that I don't have enough negative charge. So we give myself another sulfate. Well, now I don't have enough positive. And so now I have 2 iron cations, and then short on the negative right here. So if I add another sulfate, I see that, you know, I'm now 6 and 6. So iron 3 sulfate has 2 irons and 3 sulfates. So write down sulfate, and then since you have 3, like act like you're in math class, distribute it out like that, okay? Everybody cool with the chart now? Happy times. Any questions? Okay, notice again that the Roman numeral is not the number of iron. It's not. That doesn't work. That's not right. Okay, so they're doing that. I'm going to give you the hydrogen sulfate. You had that yesterday. I don't expect you to have that memorized. Hydrogen sulfate is HSO4 1 minus. It's the same as bisulfate. The rest of these, chromate is I believe that's right. Yeah. And the rest of them you should know. So I'm helping you out with that, okay? But, you know, the other ones you're already familiar with. So use the chart if you need to. If you don't need to, then don't. Your written formula should never, ever have plus or minus signs. That's the reason they bonded in the first place. So they would become neutral. There should be no plus or minus signs in these answers. I don't know if this is helping y'all out. Maybe it will. When y'all draw those little charts, you're making a circle for each particle, right? You see how parentheses kind of looks like a little circle? Like iron 2 oxide has like a 2 in a little circle. That tells you that in a little circle for that iron, you put 2 in it. You understand? 2 plus something. Let me walk with it. Let me just show you what I mean. So, if I'm working out number 2, which I'm working out number 2, what I'm saying to you is, see how this looks kind of like a 2 in a circle? Well, I guess that each little circle gets 2 pluses. That's what I'm saying. Maybe that will help you. Maybe not. Oops. Just kidding. I'm going to start putting the answers up so you can check your work as you go. If you're not finished, don't check your work yet. And if you are, then check it. Oh, chromate CrO42 minus. Oops. I got the charge on this one wrong. Will you forgive me? My bad. So since chromate is CrO42 minus, or yeah, 2 minus, you just need 1 of each. That's my mistake. I'm sorry. Anybody need my help? I'll be happy to help. The Roman numerals basically iron is going to be 2 plus 2. So it's just a charge on the iron. So in the number 2, the circle, part of the iron is 2 plus 2. But on 3, the number 3 is going to be 3 plus 2. So it's just a charge. And it's a D block. Things down here. So iron, all. So that's only default things that do that. So those things Can I help anybody? Sure. Did you get them all correct? How's it going? So I'm going to, is this for number 6? Let's check it out. Does that make sense? Start with 1 of each. That's how to do it. Alright, how y'all doing? Thanks. That was a lot better. Except for this part. Let me out with what I said. like hydrogen sulfate, like this whole thing is that. So just basically bond that little hydrogen. Okay, last little thing, and the last little thing we're going to talk about is hydrates. Now, on your quiz on Tuesday, I have hydrates as extra credit. Now, I need you all to listen to the part about hydrates because we'll be working with them later. But do you ever buy like beef jerky or vitamins or something like that, and there's like that little pack inside that you're not supposed to eat? You know what I'm talking about? It's like a desiccant. Well, it actually is a hydrate. Some salts, like if you bust that open, doesn't it look like salt inside? Well, anything that looks like a salt typically is an ionic compound. So let me tell you what's going on with your new pair of shoes or your beef jerky. There's a salt in there that's called a hydrate. Now, if you get hydrated, what did you just put inside of your body? Okay, so a hydrate is a salt that can hold water inside of its little matrix of ions. Okay, so what salt does is if I had sodium chloride is not, a hydrate typically, but if I drew out sodium chloride, it would be like a little brick, any kind of salt, and the ions are actually in little cubes. Right? If you look at a piece of salt, just a little cube, right? The ions look like that. It's not just like one atom of sodium and one atom of chlorine. They're in a big matrix. And so what a hydrate can do, if I have a little white pouch of this and the beef jerky, there's my little pillow pack, okay? What it can do is water can get absorbed up in the middle of those ions. And it soaks it up, and then your stuff stays fresh. Called a hydrate. So these are special ionic compounds that can hold water. And that makes sense, right? Hydrates, okay? But what you're going to do on these, and this is optional as far as studying and practicing them, but if you can get extra credit in here, then it's probably a good idea. What you're going to do is you're going to write the formula for the ionic compound. So, like, don't freak out yet. Sodium sulfate, you do that, right? Well, if it says decahydrate, you know that deca means 10? If you don't, well, learn it for extra credit. So all you do is just write out the formula like you already know how to do, and then you just put, in math class you do a dot for multiplication, put your little dot for multiplication, and then 10 waters. Now this can hold 10 water molecules, that's all it means. That's easy, right? No problem. Your prefixes, you have mono, di, tri, I'm drawing a blank on number 4. Penta. What is 4? Penta, hexa, hepta, octa, nona. What's 4? No. Not for this. Not for Greek stuff. I'm so sad inside. It'll come to me. Trey, come on, man. No, try. I'll look it up. I can't. Maybe it's on the next slide. Cross your fingers. Nope. But, okay, barium chloride dihydrate. Do you want to try and see if you can do it? Di means 2. Penta, hexa, hepta. Oh my gosh. I'm doubting my life and everything I've ever learned. Wyatt, do you not know what 4 is in Greek? No? Oh my gosh. I gotta look it up. You don't need it for this, but I'm doubting my life. Okay. No. I'm looking it up right now. Okay, here we go. It's tetra. 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 I'll write them up here for you in a minute if you want. Did you do this? Did you do things? That's funny. It's extra credit. Y'all get the extra credit. Okay. And then see if you can go the other way. What I'll tell you what I'll do for you is I'll list out your prefixes. Are they on your PowerPoint? No. No. Okay, I got you then. There you go. The people that are choosing to do this, are you happy inside? Okay, cool. So if you want to give this a whirl on the quiz on Tuesday, then there are practice problems on it. You should do those, and then you'll have to memorize your little prefixes, which you probably already know a lot of them. And that's all I have for today. I'm gonna pull up the answer key to your practice, and you can videotape it if you want. Everybody got this? Cool. Get your phone out if you want to videotape the answer key. If you don't, then don't.